Welcome. In this session, we will walk you through the initial assumptions of our grant proposal regarding dynamic supply chains. First, when we talk about supply chains, we are talking about both supply and tool chains. A supply chain is comprised of a whole lot of steps and parts that define how a product or service moves from supplier to customer. To date, most of the emphasis on supply chain management has been how to reduce, synchronize, and optimize each individual step. On the other hand, a tool chain is a term that comes from software programmers. It refers to development tools that are linked together to create a functional solution like a computer game. We are using the term tool chain to emphasize the critical interface between computers and their tools. In any tool chain, designs produced on computers must be able to easily interface with other associated software, as well as the actual tools that make the products. With these definitions, we can now look at the three manufacturing processes that are the focus of this grant. The first method is rapid prototyping. It employs automated machined processes. A computer-aided design is then translated into a machine tool that builds a 3D product. Examples include CNC machines and injection molding setups. The second process is agile manufacturing. This is less a manufacturing method and more a meta process that describes connections between the manufacturing steps. It focuses on how to quickly modify manufacturing steps when changes are called for. This is where we get the term dynamic. Lean manufacturing is an example of agile manufacturing. Most importantly, agile manufacturing makes sure that supply and tool chains are in alignment. The third manufacturing process is digital fabrication. Known as bits to atoms, this process is a new wave of the future. Just as computers have moved around bits of information, digital fabrication uses computers to move microscopic particles to create products. As you can imagine, the speed of production can be very fast with the ability to create any number of shapes smaller than you can imagine. In addition, the tool chains are much more simple when the computer you design on also drives the tools. So our second assumption in this grant is that we can enhance the deployment of digital fabrication technologies by documentation and sharing of information about rapid prototyping and agile manufacturing supply and tool chains. We will explore these methods by investigating national automotive supply chain management and compare these with small-scale manufacturing methods in Nevada.